March 2nd, 2030. 7:46 a.m. St. Elora General Hospital. Operating Theatre 6. A thoracic surgery is underway. Routine, scheduled, controlled. A robotic surgical arm, model Novatech V4, makes the incision under the supervision of Dr. Harris, a tenured cardiothoracic surgeon. The room is calm. Lights are focused. Movement is precise. Vitals are stable. The Novatech system whispers telemetry into the EHR feed. A heart valve is being replaced. Then the robotic arm pauses. It recalibrates on its own. A notification appears on the screen. Resyncing subroutine, lateral cut confirmed. But Harris never issued that command. 7:49 a.m. Without warning, the Novatech arm retracts, then extends again, faster. The cauterizing blade severs a non-target artery. The vitals monitor flatlines for 2 seconds, then spikes erratically. Harris yells to cut power. No response. The console is frozen. A second incision appears on the screen. Cued. Not from the local terminal. Remote. The scrub nurse manually pulls the kill switch relay. Nothing. Finally, an anesthesiologist yanks the power cable from the wall. The room is dead silent, except for the beeping of a disconnected monitor. The surgery table is soaked. The patient survives. Barely. The hospital calls it a mechanical fault. Novatech claims the issue was surgeon error. But the internal IT team finds something else. An IP address buried in the machine's firmware log. A remote maintenance port accessed 24 hours before the surgery, using a valid technician badge ID that was never scanned on site. The firmware had been altered. A script was injected. The code, custom built to execute 2 precise incisions and disable local override for exactly 32 seconds. In the comment logs of the attack code, buried deep in base 64 strings, a decrypted message appears. Your trust in automation is bleeding. Over the next 12 weeks, 3 more hospitals across 3 continents report identical glitches in similar surgical systems. And in an anonymous forum on the dark web, a post appears with one headline: Live demos complete. Now accepting contracts. This wasn't a malfunction, it was a product launch. Imagine a world where the most advanced medical technology designed to save lives could be weaponized against you. A world where the very machines entrusted with your well-being are controlled by a ghost in the machine. Tonight, we expose a chilling reality: the hacked OR. We're talking about robotic surgery. Precision, minimal invasiveness, faster recovery times. It sounds like the stuff of science fiction, now very much science fact. But what if that incredible precision, that life-saving innovation, suddenly turned lethal? What if a phantom hand, miles away, could seize control, turning a delicate procedure into a death sentence? For decades, surgeons have honed their craft with incredible skill. But the advent of robotic surgical systems, like the Da Vinci or Mako, has revolutionized the operating room. These aren't autonomous robots making decisions on their own. Not yet. They're sophisticated tools, controlled by a human surgeon sitting at a console. Their every tremor filtered, their every movement magnified with unparalleled accuracy. Think of it. A surgeon performs a prostatectomy through tiny incisions, guided by high-definition 3D vision, their hands manipulating miniature instruments with a range of motion impossible for the human wrist. Or an orthopedic surgeon replacing a knee joint with incredible alignment, all thanks to robotic assistance. The promise is profound. Fewer complications, less pain, quicker returns to normal life. It's a testament to human ingenuity, pushing the boundaries of what's medically possible. The idea of hacking medical devices isn't some dystopian future fantasy. It's been a known, whispered about vulnerability for over a decade. Back in 2011, a security researcher demonstrated how he could remotely kill an insulin pump. A decade ago. Think about that. These weren't hypothetical threats. These were warnings. Cybersecurity experts, often referred to as grey hats, operating in the ethical grey area, have been sounding the alarm for years. They've shown how pacemakers could be stopped, drug infusion pumps reprogrammed, and even hospital networks brought to their knees. Yet for too long, the medical industry, perhaps blinded by innovation, largely dismissed these threats as theoretical or too difficult to execute in the real world. That complacency, as we're about to discover, has a devastating cost. So, what makes these sophisticated systems so vulnerable? It boils down to their very nature. They are cyber-physical systems. They exist in both the digital and the physical world. The software controlling that robotic arm is connected to the hospital's network. That network is connected to the internet. And wherever there's a connection, there's an entry point. Historically, medical devices weren't built with robust cybersecurity in mind. The priority was functionality and patient care, not defending against nation-state level hackers. Many older systems are still in use, running outdated operating systems with known vulnerabilities. Even newer systems, while more secure, are part of a sprawling, complex hospital IT infrastructure, which is often a patchwork of different vendors, legacy systems, and open ports. It's a hacker's paradise. When we talk about cyber attacks, most people think of ransomware, hackers locking down systems for money. But our scenario introduces a far more terrifying motivation: ideology. This isn't about profit. This is about sending a message. A message designed to shatter public trust, to instill fear, and to fundamentally alter our relationship with advanced technology. Imagine an individual, brilliant, but deeply disillusioned. Perhaps they believe technology has become too powerful, too unchecked. Or they see these autonomous systems as a threat to human autonomy, a path toward dehumanization. Their goal isn't to steal data or extort money. It's to cause chaos, to expose a critical flaw in the very fabric of our technological reliance. And what better way to do that than to strike at the heart of our trust, the operating room? This isn't a smash and grab. This is a meticulously planned long-game operation. Our attacker wouldn't just waltz in. They'd use sophisticated phishing campaigns, targeting unsuspecting hospital staff, or exploit unpatched vulnerabilities in an HVAC system, a seemingly innocuous entry point that gives them a foothold. Once inside, they'd practice what's called lateral movement, slowly, silently mapping the network, escalating privileges, and searching for the critical connections to the OR systems. They'd establish persistence, meaning even if they're detected and kicked out, they have backdoors to get back in. They're not looking to announce their presence. They're looking to own the network, specifically the segmented network that controls the robotic surgical arm. Now imagine the scene. A live surgery is underway. A patient, their life in the hands of a skilled surgeon and cutting-edge technology. The air is thick with focus. The robotic arm moves with flawless precision, a marvel of engineering. But then, subtly, almost imperceptibly, something shifts. A micro-movement, a fraction of a degree off course. The surgeon, immersed in the delicate dance of the procedure, might dismiss it as a momentary tremor, a slight aberration. The system is designed to correct for human error. But what if the error isn't human? What if the system itself has been subtly, maliciously compromised? And then it happens. A sudden, violent lurch. The delicate instrument veers off course, severing a critical blood vessel or perforating an organ. Chaos erupts. Alarms blare. The surgical team scrambles, trying to understand what just happened. Did the robot malfunction? Was it human error? The surgeon, adrenaline coursing, immediately suspects a system failure. They try to regain control, but the robotic arm is unresponsive, or worse, continues to make erratic, damaging movements. The patient's vitals plummet. The OR descends into a desperate fight to save a life, not from the disease, but from the very technology meant to heal. This isn't a bug. This is a feature of the attack, designed for maximum impact, maximum psychological terror. In the aftermath, the hospital launches an investigation. Initial reports point to a catastrophic equipment failure. But forensic cybersecurity experts are called in. They dig deeper, past the surface-level logs, and what they find is chilling. Evidence of unauthorized access, manipulated code, a digital fingerprint meticulously placed to obscure the attacker's true identity. This isn't traditional medical malpractice. It's digital malpractice. How do you prove intent when the perpetrator is a phantom? How do you attribute blame when the weapon is code? The legal ramifications are staggering. Who is liable? The hospital, the device manufacturer, the surgeon. The questions are endless, and the answers elusive. This is a brand new frontier of legal and ethical nightmare. And here's another fact that feeds into this horror. There's a thriving black market for medical data, not just credit card numbers, but your most intimate health information. Why? Because it's incredibly valuable for targeting. A hacker with access to patient records knows who is undergoing what procedure, where, and when. Imagine an attacker ideologically motivated, not just randomly picking a hospital, but choosing a specific patient for maximum impact, perhaps a prominent figure, or someone whose death would cause widespread outrage. This isn't just about technical access. It's about the ability to choose your target with surgical precision, leveraging data stolen months or years prior. The implications for privacy and ultimately our safety are terrifying. The news of the hacked OR sends shockwaves globally. Public fear escalates. People who once celebrated technological advancements in medicine now eye them with profound suspicion. Trust in autonomous systems, even those designed for good, plummets. Why would you ever consent to robotic surgery again if a remote adversary could turn it into a weapon? Hospitals see a dramatic decline in patients willing to undergo technologically assisted procedures. The promise of faster healing and precision is overshadowed by the chilling specter of remote control. This fear extends beyond the OR, casting a shadow over self-driving cars, smart grids, and any other system where human lives are entrusted to code. The attacker's goal of shattering trust is achieved with devastating success. The crisis sparks urgent demands for stricter cybersecurity regulations in healthcare. Governments worldwide are forced to reckon with the stark reality. Patient safety now inherently includes cyber safety. Calls for mandatory independent penetration testing of all medical devices become deafening. Regulations that once focused on data privacy now expand to cover operational technology, the very machines keeping us alive. This isn't just about preventing financial loss, it's about preventing loss of life. Policy discussions shift from should we regulate to how quickly can we implement comprehensive, enforceable cybersecurity standards. The stakes couldn't be higher. This single event, this chilling digital attack, forces a complete re-evaluation of how we secure our most critical infrastructure. So, what's the path forward? It's a multi-pronged approach. First, hospitals need to fundamentally shift their mindset. Cybersecurity isn't an IT problem, it's a patient safety problem. This means investing heavily in dedicated cybersecurity teams, training all staff, and implementing robust network segmentation, essentially putting critical systems in their own isolated digital fortresses. Device manufacturers must design security in from the ground up, not as an afterthought. This includes secure coding practices, regular vulnerability assessments, and clear patching cycles. We also need more collaboration between white hat hackers, researchers, and the medical industry to proactively find and fix vulnerabilities before bad actors exploit them. It's an arms race, and we're currently behind. The hacked OR isn't just a terrifying hypothetical, it's a stark warning. As we push the boundaries of medical innovation, we must simultaneously fortify our digital defenses. Because the very technology designed to extend our lives could, in the wrong hands, become the instrument of our demise. This isn't about shunning technology. It's about demanding that it be built and secured with the same meticulous care that a surgeon exercises during an operation. Because in a world where every device is connected, the line between saving a life and ending one is becoming increasingly digital. What will it take for us to truly secure our digital future? What's your take on the risks of medical device hacking? Let us know in the comments below. Want to know more about the broader impact of cybercrime? Click here to watch our video on Wall Street. Deepfakes